Hello students, welcome to the lecture on Object Relational Database, and after this lecture we will be able to learn the following objectives. Understand the concept of Object Relational Database, discuss about advantages and disadvantages of Object Relational Database, describe the nested relations, understand the concept of complex types and object orientation, and explain the nesting and unnesting. Let us start with Object Relational Database. An Object Relational Database ORD or Object Relational Database Management System ORDBMS is a database management system DBMS similar to a relational database but with an object-oriented database model. Objects, classes and inheritance are directly supported in database schemas and in the query language. In addition, just as with proper relational systems, it supports extension of the data model with custom data types and methods. An object relational database can be said to provide a middle ground between relational databases and object-oriented databases OODBMS. Extend the relational data model by including object orientation and constructs to deal with added data types. Allow attributes of tuples to have complex types, including non-atomic values such as nested relations. Preserve relational foundations, in particular the declarative access to data, while extending modeling power. Advantages of Object Relational Database. Object relational databases combine the features of both relational databases and object-oriented programming. This means that when developing these databases, we can include methods and data types. This increases your ability to sort through and locate files within these databases faster. By assigning these data types to your files, you can better filter them through the database. Object relational database capabilities are extended with the addition of new data types, access methods and functions found in object-oriented programming. You can add string characters with alphanumeric data types. Complex data types can combine characteristics of data types that already exist in your database. You can specify data types by the text you wish to contain or by the amount of bytes used to create it. User-defined data types can be opaque or distinctive. Object relational databases allow the use of inheritance. Within inheritance, you can develop classes for your data types. These objects can inherit certain capabilities from other classes to be used in other functions of the database. These inherited properties could be something simple like all files within class A are insurance claims. So if you program class B to inherit class A characteristics, then class B will also be insurance claims, but they could also be insurance claims that have been processed recently. Through inheritance, your data types will inherit these features of other data types. Polymorphism in object relational databases involves allowing one operator to have different meanings within the same database. You can connect your tables within your database by building relationships. This includes records that may all contain the same name but different information. You would use encapsulation with object relational databases in the form of tables to include name, address, telephone number and email address for your contacts. Through encapsulating the contacts class, you combine all of this information into this one table, so that when you query the database for this information, you generate a report in the style of a form to include all of this information. Complexity, increased costs, components of relational approach believe simplicity and purity of relational model are lost. Some believe RDBMS is being extended for what will be a minority of applications. OO purists not attracted by extensions either. SQL now extremely complex. Nested relations. 1NF requires that all attributes have atomic, indivisible domains. The nested relational model is an extension of the relational model in which domains may be either atomic or relation valued. This allows a complex object to be represented by a single tuple of a nested relation, one-to-one correspondence between data items and objects. Motivation. Permit non-atomic domains, atomic indivisible. Example of non-atomic domain, set of integers or set of tuples. It also allows more intuitive modeling for applications with complex data. Intuitive. Allow relations wherever we allow atomic scalar values. Relations within relations. Retains mathematical foundation of relational model. Remove awkwardness of ad hoc by assuming that the following multi-value dependencies hold: title to author, title to keyword, title to day, month, year. Decompose at doc into 4NF using the schemas title author, title keyword, title day, month, year. 4NF design requires users to include joins in their queries. NF relational view at doc, defined by join of 4NF relations, eliminates the need for users to perform joins but loses the one-to-one correspondence between tuples and documents. Nested relation representation is much more natural here. Complex types and object orientation. The extensions include nested relations, nested records, inheritance, reference to objects, and other object-oriented features. The presentation is based on a draft of SQL3 with the incorporation of features from XSQL and Illustra. Collection and large object types of nested relations are an example of collection types. Nested record structures like composite attributes, inheritance, object orientation, including object identifiers and references. Not fully implemented in any database system currently. Collection types. Create table books, keyword, set of varchar 20. It is a relation doc with complex attributes, sets, and structured attributes. It allows type definition recorded in the schema stored in the database. One can also create table directly without creating an intermediate type for the table. Complex type systems usually support other collection types such as arrays and multisets. Example, author array. My string 10 presents an ordered list of authors. Inheritance can be at the level of types or at the level of tables. It also allows an object to have multiple types by allowing an entity to exist in more than one table at once. Consistency requirements on subtables and supertables. Inherited attributes other than the primary key of the supertable need not be stored and can be derived by means of a join with the supertable based on the primary key. As with types, multiple inheritance are possible. Multiple inheritance. Since name and social security are inherited from a common source, person, there is no conflict by inheriting them from student as well as teacher. However, department is defined separately in student and teacher, and one can rename them to avoid a conflict. Inheritance makes schema definition natural, ensures referential and cardinality constraints, enables the use of functions defined for supertypes on object belonging to subtypes, and allows the orderly extension of a database system to incorporate new types. Reference to objects. An attribute of a type can be a reference to an object of a specific type. Example, ref person. Reference to tuples. Tuples of a table can also have reference to them. Example, ref people. It can be implemented using the primary key or tuple ID. SQL 3 uses identify for tuples and void for objects. The kind of action or activity proper to a person, thing or institution, the purpose for which something is designed or exists, role. Querying with complex types. Our extended SQL allows an expression evaluating to a relation to appear anywhere that a relation name may appear. The ability to use sub-expressions freely makes it possible to take advantage of the structure of nested relations. Aggregate functions can be applied to any relation valued expression such as select from name, PDO count, author list. An expression of the form student advisor name is called a path expression. References can be used to hide join operations, and thus the use of references simplifies the query considerably. The transformation of a nested relation into one NF is called unnesting. Example: to complete unnest the doc relation, we have select name, A as author, date, day, month, date, year, K as keyword from doc as B, author list as A, B, keyword list as K. The reverse operation of transformation of a one NF relation into a nested relation is called nesting. Example: to nest the relation at doc on the attribute keyword, we have select title, author, day, month, year as date, set keyword as keyword list from flat doc, group by title, author, date. Object relational systems allow functions to be defined by users. Functions can be defined in a data manipulation language such as extended SQL. In general, a select statement can return a collection of values. If the return type of a function is a collection type, the result of the function is the entire collection. However, if the return type is not a collection type, the collection generated by SQL should contain only one tuple. Otherwise, a system may have two choices: flag an error or select an arbitrary one from the collection. Functions can also be defined in a programming language such as C or C++. It can be more efficient and handle more complex computations than that defined using SQL. Embedded SQL is different from C++ code functions. In embedded SQL, the query is passed by the user program to the database system to be run. User-written code never needs to access to the database itself. The operating system thus can protect the database from access by any user process. Creation of complex values and objects. Create and updates tuples with complex types, tuple valued and set valued. Example: insert into doc values, sales plan, set, Smith, Jones, 1 April 89, set, prot, strategy. We can also use complex values in queries anywhere in a query where a set is expected. We can enumerate a set like select name, date from doc, where name in set, sales plan, opportunities, risks. To create new objects, we can use constructor functions. The constructor function for an object type T is T. When it is invoked, it creates a new uninitialized object of type T, fills in its void field and returns the object. The fields of the object must then be initialized. Comparison of object-oriented and object-relational databases. Object-relational databases are object-oriented databases built on top of the relational model. The declarative nature and limited power of the SQL language provides good protection of data from programming errors and makes the high-level optimization, such as reducing I/O, relatively easy. Object relational systems aim at making data modeling and querying easier by using complex data types. Typical applications include storage and querying of complex data, including multimedia data. Persistent programming language-based OODBs target applications of that form that have high performance requirements. No data translation needed, low overhead access to persistent data, but more susceptible to data corruption, to programming errors, and usually do not have a powerful querying capability. Typical applications include CAD databases, relational systems, simple data types, powerful query languages, high protection. Persistent programming language-based OODBs, complex data types, integration with programming languages, high performance. Object relational systems, complex data types, powerful query languages, high protection. Some systems blur the boundary. Example, some object-oriented database systems built around a persistent programming language are implemented on top of a relational database system. Relational database management systems. The relational model code described had three parts: a data model, a means of expressing operations in a high-level language, and a set of design principles that ensured the elimination of certain kinds of redundant data problems. CORD's relational model views data as being stored in tables containing a variable number of rows or records, each of which has a fixed number of columns. Something like a telephone directory or a registry of births, deaths, and marriages is a good analogy for a table. Each entry contains different information but is identical in its form to all other entries of the same kind. The relational model also describes a number of logical operations that could be performed over the data. During the several parallel research projects set out to implement a working RDBMS, this turned out to be very hard. It wasn't until that RDBMS products worked acceptably in the kinds of high-end online transactions processing applications served so well by earlier technologies. Despite the technical shortcomings, RDBMS technology exploded in popularity because even the earliest products made it cheaper, quicker, and easier to build information systems. For an increasing number of applications, economics favored spending more on hardware and less on people. RDBMS technology made it possible to develop information systems that, while desirable from a business management point of view, had been deemed too expensive. Summary. Now, in the end, let us summarize what we have learnt in this lecture. An object relational database can be said to provide a middle ground between relational databases and object-oriented databases, OODBMS. The basic goal for the object relational database is to bridge the gap between relational databases and the object-oriented modeling techniques used in programming languages such as Java, C++, Visual Basic, .NET, or C#. Object relational databases combine the features of both relational databases and object-oriented programming. Unlike relational databases, object relational databases allow the use of inheritance. Within inheritance, you can develop classes for your data types. Polymorphism in object relational databases involves allowing one operator to have different meanings within the same database. Inherited attributes other than the primary key of the supertable need not be stored and can be derived by means of a join with the supertable based on the primary key. The transformation of a nested relation into one NF is called unnesting. The reverse operation of transformation of a one NF relation into a nested relation is called nesting. Object relational systems allow functions to be defined by users.